In this video, we're going to talk about implicit differentiation. Up until now, we've been determining derivatives when y is stated explicitly in terms of x. So for instance, y equals 3x squared plus 1, the y is already isolated. However, sometimes an equation defines y implicitly as a differentiable function of x. When that happens, we need to differentiate each side of the equation in terms of x and remember to use the chain rule when differentiating terms containing y. An example would be 3xy squared plus 5x squared y equals 7. We don't have y explicitly stated in terms of x. It's not isolated on one side. And so when that happens, we want to have the chain rule, and the chain rule will actually end up being useful even in, we want to use implicit differentiation, and implicit differentiation will actually be useful in cases even where theoretically we could isolate the y. It's still a useful thing to know. And you'll notice earlier I meant to say implicit differentiation and I said chain rule. Well, that's because implicit differentiation is just a subset of the chain rule. Okay? So before we get into it, let's just talk briefly about the chain rule, something that's been alluded to earlier. If I asked you to give me the derivative of 5x cubed, most of the time people simply say 5x squared. But technically, 15x squared. But technically what they should do is they should then also differentiate the base of the exponent with respect to x. So they should technically multiply the 15x squared by the derivative of x with respect to x. Now, the derivative of x with respect to x is just 1, and so it doesn't change the result, and so usually we don't show that. And so that's what's written in this sentence right here. The derivative of 5x cubed with respect to x is 15x squared dx dx. But since dx over dx equals 1, therefore the derivative of 5x cubed with respect to x is simply 15x squared. But if I give you 5y cubed and I ask you to give me the derivative of that with respect to x, in this case the base of the exponent is y. So the derivative of 5y cubed will be 15y squared. But then, like the chain rule says, I then have to multiply by the derivative of the base of that exponent. And since I'm determining derivatives with respect to x, I'll end up with 15y squared dy over dx. And sometimes when we're being, writing quickly, we sometimes will say 15y squared y prime. Okay? So what a lot of students end up remembering is that if they're determining derivatives with respect to x, but they use the power rule on another variable, say for instance y, they need to put a dy dx as a factor next to that. And it's all because of the chain rule. So suppose you were given the equation x squared plus y squared equals 4. You want to determine dy over dx and determine the slope of the tangent at the point 3, negative 4. Well, we recall from grade 10 math that this is a circle with a radius of 5. It actually looks like what you see on the screen. There's a circle with a radius of 5. There's a point 3, negative 4, which is on the circle because it meets the condition that x squared plus y squared equals 25. And so what we want to do is figure out the slope of that tangent line. Well, all we're going to do is determine the derivative of each one of these three terms with respect to x. So the derivative of x squared with respect to x is 2x. If we want, we could say times dx over dx, but that's not necessary. Plus, now the derivative of that second term, y squared, that's 2y, and we should determine the derivative of the base of that exponent with respect to x, so that since the base is y, we should multiply by dy over dx. Now putting in the dx over dx isn't necessary because it equals 1, but putting in the dy over dx, you better believe that's necessary. And that's going to equal the derivative of 25 with respect to x. Well, 25 never changes, so its rate of change will be 0. And you all know that when you determine the derivative of a constant term, the answer is 0. So like we said earlier, we don't need to show this dx over dx, so most people's first line of their solution will just say 2x plus 2y dy dx equals 0. Now we're just going to subtract 2x from both sides. We're going to divide both sides by 2y. And notice what we've now done is we've isolated dy over dx. They asked us to determine dy over dx, and we've just determined it. It's equal to negative 2x over 2y. We haven't learned our simple rules of fractions, so we know we can reduce that exponent to negative x over y. There's our expression for dy over dx. Now they say, what's the slope of the tangent to the curve at the point 3, negative 4? The slope of the tangent to a curve is simply the value of dy over dx at that point. So since we're talking about the point 3, negative 4, that means x is 3 and y is negative 4. So at 3, negative 4, dy over dx will be negative x over y, or in other words, 3/4. So what we're saying using implicit differentiation is that the slope of that tangent is 3/4. That looks about right. One more question we'll try is this one here. Let's determine dy over dx for this relation. So what we're going to do is determine the derivative of the first term with respect to x. Applying the power rule to 6y cubed, we get 18y squared, but we have to multiply by dy over dx. Now we have another term here, 3xy. I'm going to think of this as a product. I'm going to think of it as 3x times y. Now I'm going to use the product rule. So the derivative of 3x with respect to x is 3, times the second, which is just y, plus the first, which is just 3x, times the derivative of the second with respect to y. The derivative of, with respect to x, I apologize. This is all with respect to x. So the derivative of y with respect to x is, by definition, dy over dx. And then that's going to equal the derivative of 7 with respect to x, and that's just going to be 0. Okay, so one way to think about this dy over dx that's right here is to say the derivative of y with respect to x by definition is dy over dx. Another way to look at it, and some students do this, is they look at that y and they say, well, I need to apply the power rule to that. So I get 1y to the 0. Well, y to the 0 is 1, so they just have 1. But they still have to multiply by dy over dx since they were applying the power rule to a variable other than x. So however you think about it, you have to know that the derivative of y with respect to x is this dy over dx term. Now, what we're ultimately trying to do is isolate that dy over dx, because that's what the question wants. So we'll just do a little subtracting. 18y squared dy over dx minus 3y minus 3x dy over dx is equal to 0. I've got two terms on the left with dy over dx in them, so I will keep those two terms on the left, and the other term, I'll throw that over onto the right side of the equation. I'll factor out dy over dx from both of those terms. And now I will divide both sides by 18y squared minus 3x. Now, at this point, you could say you're done, but it is actually possible to reduce that fraction. So we'll say it's 3 times y, and then it's also 3 times 6y squared minus x. And so we can cross those 3's out. And so our final answer as a reduced expression will be that dy over dx equals y over 6y squared minus x.